So hello everyone, so today we'll be starting the initial module of ASP.NET MVC. So as part of that we'll be starting with initially the differences between ASP.NET and MVC request lifecycle comparison. So the purpose of this module is in terms of the class is like normally we have different request lifecycles for ASP.NET as well as MVC. So we'll see how ASP.NET initially how ASP.NET request lifecycle executes, then we'll come to the comparison of MVC request lifecycle. So let's start with ASP.NET lifecycle. Hello. So we initially will see the ASP.NET request response architecture, then we'll go to the MVC request lifecycle. Normally ASP.NET MVC is a framework which is used for developing dynamic web applications. It primarily uses .NET framework. Prior to ASP.NET MVC, dynamic web applications were based on the .NET framework. They were developed using ASP.NET web pages and web forms. Now ASP.NET is a server-side technology, as you know, that enables us to create dynamic web applications using advanced features, which is used for scalable, security and simplicity. Now ASP.NET web applications, they comprise of ASPX web pages that includes both client-side as well as server-side scripts to build dynamic web pages. So now when the request comes from a client to a server, a lot of operations will be performed before sending back to the client. So now let's see about how is the IAS processing of the request when the request is coming from a client to a server. Now before going to that, let's see what is a web server is. So when we run our ASP.NET web application from our Visual Studio IDE, this ASP.NET engine is responsible to execute all kind of ASP.NET request as well as response. Now primarily the process name is webdev.webserver.exe, which will take care of all our requests and response of a web application. Now the web server name which comes into picture is where we want to host our application on a centralized location and can be accessed globally across all the locations. So web server is responsible to handle all the requests that are coming from clients and process them and provide the responses. So what is IAS now? So IAS is nothing but Internet Information Server, which is the most powerful web server from Microsoft and which is used to host the ASP.NET web application. IAS has its own process engine which is used to handle the ASP.NET request, so that when a request comes from a client to a server, IAS will take the request and process it and sends back to the client. Now if we see, this is how, if we see the diagrammatic representation, the client is requesting for some information and server is receiving the request, and internally Internet Information Server will process the request and send it back to the client. Now when we see the IAS request response architecture internally, as I told you, there is a worker process which is called w3wp.exe that runs the ASP.NET application in IAS. This process is responsible to manage all the request and response which is coming from a client system. Now all the ASP.NET functionality runs under the scope of a worker process. So now we'll see how the internal architecture runs inside the IAS. Now when a request comes to a server from a client worker process, this worker process is responsible to generate the request and response, and we can say that this worker process, which is w3wp.exe, is the heart of ASP.NET web application which will run on IAS. Now the next term which we need to learn is what is an application pool. So application pool is a container of all the worker process. So an application pool is used to separate sets of IAS worker process that share the same configuration. Now if we see the hierarchy, initially we have started with worker process. So worker process is the heart of the ASP.NET web application. All these worker process, sets of worker process will be stored in application pool. So that's the reason we say that this application pool is responsible to separate sets of IAS worker process that will share the same configuration. Now why do we need application pool? We need application pool because we need to provide better security, reliability, and that will give the availability for any web application. Now worker process will serve as a process boundary that will separate each application pool so that when one worker process or application is having an issue, or we have an issue with the recycling, the other applications or the other worker process will not be affected. And this will make sure that our particular web application doesn't impact the other web applications, because they will be configured in different application pools. So if you see the diagrammatic representation, we have a client that can be a machine or the browser that will send the request to the internet over an internet, and it will reach the IIS, which is the Internet Information Service, and inside the IIS will have this worker process which will take that request, and if it requires to get the data from the database, it retrieves the data from database and sends back the response, and the response will reach the client in terms of an HTML file. Now let's see the next in terms of the process architecture of a worker process. So if you see here in the first diagram, we have a section of worker process. So normally when we have an application pool with a set of worker process, that's called a web garden. Now if you see the IIS architecture, we can divide them into two layers. So one is the kernel mode and the second is the user mode. These two modes are pretty much important for every request that reaches IIS. Now let's see what is kernel mode and what is IIS mode. Now when we say kernel mode, it was introduced with IIS 6 and it contains an important process called http.sys. This http.sys is pretty much heart of the kernel mode, because whenever a request comes from a client to a server, it will hit first the http.sys. Now when it reaches the http.sys, that is responsible for passing the request to a particular application pool. Now we may have a question like, why do we need a http.sys and how does it recognize like this particular request is mapped to a particular application pool? So this is not a random pickup, but whenever we create a new application pool, what it happens is the application pool ID will be generated and will be registered with http.sys process. So whenever http.sys receives a request from any web application, it checks for the application pool and based on the application pool it sends the request back. So if you see here in the diagram, I have an http.sys and where each application pool ID will be registered with the http.sys. So now till now we have seen that client requested for information and request came to the kernel mode of IIS, that is at http.sys, and http.sys has identified the name of the application pool where it to send it to. This is about the kernel mode. Now let's look at the user level of IIS. In user level of IIS, we have an important service which is called Web Admin Services. It's called WAS. What is the responsibility of WAS? It will take the request from http.sys and sends it to the respective application pool. So that's the responsibility of WAS, which is nothing but Web Admin Service. When application pool receives the request, it will simply pass the request to a worker process. So it will reach, the initial request will reach http.sys, which is part of kernel level, then it reaches Web Admin Service, which is part of user level of IIS, then from there it will reach the respective application pool. So as I told you earlier, the application pool will contain a worker process, that's nothing but w3 wp.exe. So what is the purpose of w3 wp.exe? What it does is, it will look up the URL of the request so that it can load the correct ESAPI extension. So why do we require ESAPI extension is, ESAPI extension are the way how our IIS will handle the request for different resources. Now how does ESAPI.dll come into picture? Let me give some background on that. So whenever an ASP.NET framework is installed on a machine, what it does is, it will install its own ESAPI extension which is called ASP.NET_ESAPI.dll. So and it will add the mapping into IIS. So whenever our request comes, into our w3 wp.exe, it will look up the URL of the request and it will load the respective esapi.dll. So what is the next step? The next step is worker process will load the correct ASP.NET underscore esapi.dll, and this will start a HTTP runtime. Normally HTTP runtime is pretty much important in terms of processing the request and response. This will be the entry point of an application. So now what is HTTP runtime? HTTP runtime is a class which calls a process request method. This process request method is responsible to start the processing of a request. So when these methods are called, a new instance of HTTP context will be created. This is accessible using HTTP context.current property. Now what happens is, whenever the request object is still there, it will still remain alive during the lifetime of a object request. Now using this HTTP context.current, we can access some other objects which are like request, response, session, etc. Now we need to see what is the thing that will happen inside an HTTP runtime. Now once the request reaches HTTP runtime, then it reaches HTTP context where we can access the object. The next step it will happen is, once the HTTP runtime load happens, it will load an HTTP application object. So each and every request should pass through this HTTP application object which will internally contain the HTTP module. Now from the HTTP module, it will reach the HTTP handler, where HTTP handler will be the last step of the execution. Now all this concept of processing the request right from HTTP runtime to HTTP handler is called an HTTP pipeline, because HTTP pipeline contains complete request and response processing. Now if you see the HTTP modules, those are classes actually that will have access to the incoming request. Now normally we can also create our own HTTP modules. Now when do we create HTTP module? Whenever we need to handle anything which is during an upcoming request or a response. So as I told you, HTTP handlers are the last endpoints in the HTTP pipeline. So whichever the requests that are passing through all these HTTP modules should definitely reach HTTP handler. So now let me summarize the request and response again. So client request, when the client request, the request goes over the internet, it reaches the kernel level of IIS where we have the http.sys object, and http.sys object, as I told you, will have a mapped application pool ID, and from that mapped application pool ID it will pass through the web admin service. Now we enter into the user level of IIS. So WAS will have all the worker process requests where it will send it to the respective application pools, where internally each application pool can contain multiple worker process, and every worker process will load the respective ASP.NET underscore esapi.dll. Then through that it will reach the HTTP runtime. As part of the HTTP runtime, it will reach the HTTP context. Then through that it will reach the HTTP application. From HTTP application, it will have different HTTP modules, where the HTTP modules will be responsible for processing the request and response, and from that it will reach the HTTP handler. So HTTP handler will be the endpoint of the request, where it will process and it will give back the response back. So the response will travel through the same way from again application pool to WAS to HTTP sys, and the response will reach over an internet to the client machine. Thus the output will be in terms of an HTML output, and this will be the final output for which the request has been asked for and the response will be sent for. So this is the summary of ASP.NET page life cycle. I wanted to give you an heads up on this because it's pretty much important when we try to learn our MVC request lifecycle, because as you know, ASP.NET MVC is a framework again, which is an over our ASP.NET Web Framework. But if we have a knowledge on ASP.NET Page Lifecycle as well, then we will better understand the MVC request lifecycle. So in this way, we can have the differences between, or the comparison between ASP.NET Page request lifecycle as well as the MVC request lifecycle. Hope you understood the initial summary of ASP.NET Page Lifecycle. Now let's move on to the MVC request lifecycle. Now the MVC request lifecycle also involves a series of steps which is used for processing the client request. See, regardless of the technology or the platforms, every web framework will have its definite request lifecycle, and where MVC will not be a different one from all the web frameworks. So now understanding the different life cycles, whether it can be ASP.NET or MVC, will help us to know the better processing of the request which is requested by our client. Now to start with the MVC request lifecycle, the entry point for every MVC request lifecycle is the URL routing module. Now what do you mean by routing? Now in MVC, routing is nothing but whenever a request is coming from a client, it has to go to a definite controller action method so that it can hit the definite target in terms of reaching the definite action method which is requested by the client. So that's the reason every request which is made in terms of MVC web framework, the first entry point is URL routing module. Now let's to MVC request lifecycle, and we know that MVC applications also use Internet Information Services, which is the IIS, and once the entry point is the URL routing module, the incoming request which is from the IIS pipeline will be handed over to the URL routing module. We have seen that in ASP.NET Page Lifecycle, the initial entry point was HTTP runtime or HTTP pipeline. So here we'll have slight deviation there, where once the request reaches IIS pipeline, it will switch over to URL routing module. Now what is the importance of URL routing module? This URL routing module will analyze the request and it will look up the routing table to figure out what is the controller for which the incoming request will map to actually. Now what do you mean by routing table? See, routing table will contain all the routes which are defined in the MVC application. It will be a static container. It's a container of all definite routes which are part of our regular MVC application. Now what does the route table contain? It will contain, for this route, what should be the incoming request controller action mapping. We know that MVC application contains the controller and action methods. So this route table will contain what is the incoming request and what should be the respective controller action mapping. Now if the route is found in the routing table, then the MVC route handler will execute and brings the instance of a MVC HTTP handler. Now combination of MVC route handler and MVC HTTP handler will be the gateway for this MVC framework. Now MVC handler, once it receives the request, it will begin the initialization and start executing the controller. Now what is the purpose of controller? Because it will execute the respective action methods and it will contain the respective action methods. After this, MVC HTTP handler also takes care of converting this route data into a respective action methods, where it will have the controller specific action methods where the controller will be responsible for serving the definite requests. Now how does this controller initialization takes place? It takes place with the help of a controller factory and activator, which are responsible for creating an instance of a controller. Now many of us have a definite doubt that how does, we have seen that there is a route table, and inside the route table we have the definite route mapping. Now how does this controller execute or instantiate? Now the main activity behind this is, or the component behind this is a controller factory and an activator. Both these will initialize the controller, which will create an instance of a controller, and through this controller all our action methods will be executed. Now once we have this controller instance created, the next major step is to find the corresponding action method. Now who does this corresponding action method to execute? There is a component called action invoker, which will find the action and execute the action which is defined in a routing table. Now before the action method is called, model binding takes place. Model binding is nothing but we are tightly binding the model to the controller, or we are passing the model to the controller that will map the data from the HTTP request to the action method parameters. Now keep in mind, we are seeing the architecture of MVC request lifecycle, and when we go into the next set of classes, we will be seeing what is routing, what are controllers, what are action results, what are action filters, what are model binding, what is a view, etc. So now just understand the high level architecture of MVC request lifecycle, and when we go into the depth of the other classes, we will be knowing about each and everything in detail. So where were we? So definitely action invoker will execute the action method, and inside this action method there will be model binding. The model binding is nothing but which will map the data from the incoming request to the action method parameters. So as a next step, what it happens is it will execute the action filters. After model binding takes place, the next step is action filters, which are invoked using some of the methods which are contained in the action filters. So they will have action execution as well as action executed. So both these methods are responsible for executing the definite actions inside the filters. So once the action method has been finished, the next step is result execution. So then in the next step, which is the result execution, MVC separates the action declaration from result execution. We see that from the figure, action execution is done differently and the result execution is done differently. So if the result from the action execution is view, then depending on the configuration, we'll have ASPX or Razor View Engine, which will be called as part of the result execution. So that view will be as a response of HTTP request. So we see that after the result has been executed, the next step is the view engine, which will render the view. It can be an HTML format. So that HTML format will be executed and send it back as a response to the user. So in this class, we have seen the comparison between ASP.NET and MVC request lifecycle. So in the next class, we'll be looking in terms of in depth of MVC request lifecycle. So how are the execution taking place right from HTTP request as well as HTTP handlers, as we have seen in the ASP.NET request lifecycle. Also we'll be seeing the HTTP handlers and role of HTTP handlers, HTTP modules, HTTP context in ASP.NET MVC. And also we'll be looking at, on a high level note, how is a controller initialized, how are the action methods executed, and how are the filters, what is the scope of the filters, and finally how are the views rendered. So this is a high level architecture class for the comparison of ASP.NET with MVC request lifecycle. So in the next class, we'll be going into the depth of these building blocks of MVC request lifecycle, where the building blocks are routing, controller initialization, action execution, result execution, the view engine, and the response to the client. Thank you very much.